screen one. All right. So just to give you a quick, gotta hit this. A quick idea of what we're going to cover today. So we're going to go to the container security basics. So we're mostly going to focus on the runtime side of. Can you see my presentation or?
Yes, we can.
Okay. So we're mostly going to focus on the runtime environment rather than the actual development phase. That's a whole other bowl of fish, I guess. So we're only going to focus on this little segment, which on its own is not that little. So we're mostly going to go to containers in general, just the relevant principle that's going to be interesting for us from a security perspective. And then we're quickly going to cover Docker, just deep enough so you can actually finish the CTF that we're going to do later on. So nothing too deep. And then if there's any questions, I'm happy to answer it. I have a tendency to be overzealous when it's about security, and I tend to be sometimes a bit quick and not cover things that might not be that obvious. So please, at any time, stop me, ask me anything. I'm happy to answer questions. And then once I manage to answer all the questions, so if there are no questions, then we're going to basically go into a platform and then do a short capture the flag. It's going to be guided just to avoid leaving anyone behind. But still, you can get your hands dirty a little bit. I'm not going to give you the answer. I'm just going to show you how to get them. So we sent out an email about 40 minutes ago, I think so, with your credentials. If anyone didn't get this, please let us know. We can either create an account if you didn't register in time, or just reset your password if you're missing the credentials. So, okay, containers. One of the reason containers became so popular, in my opinion, is that they're just so easy to work with. It's so lightweight to work with. So from a developer's perspective, that's the main reason I think it gained traction there. And from an operational perspective, it's really useful to have something that has low footprint, really easy to spin up. It takes microseconds to spin up a new container. And because of that, it's a really scalable structure. Obviously, this is more of a TLDR than a proper summary. But what exactly is behind it? How does it? So it often compared to virtual machines for obvious reasons. So what are the main differences? And I'm solely going to focus on security relevant differences. So a VM is basically going to virtualize you the whole hardware, which means everything from the kernel up is separated. So all of the virtual machines have a different kernel. When they interact with the hardware, they do it on a different with a different syscall. If we're talking about containers, containers are just basically a group of processes in a Linux environment that are separated from each other with certain technologies that we're going to touch on. But essentially, they are just a group of processes on that Linux host, right? They share the same kernel, so all of the syscalls are going to go through the same kernel. They're going to access the same hardware. So that pretty much means that if there is an issue in your kernel, like there's a kernel exploit that someone can run in one of your containers, that's going to affect the whole host, right? Because the kernel is the host, basically. I mean, that's a really short summary. There's a lot of different things there, but that's I think the gist of it. So basically, it's just a group of processes. As I said, it's usually managed by, not usually, all the time, it's managed by a runtime engine. This can be containerd. In case of Docker, it can be Cryo, Podman, LXC. There's a lot of things. If you are really interested in this part, I highly recommend Liz Rice's presentation. You can find it on YouTube, where she actually builds like a really minimalistic container environment from scratch and go, just to show you how it's actually operated. It's a really informative discussion. So, as I said, it's basically a group of processes separated somehow. So there's three major technologies that they use to separate these processes. The first one is control groups. So control groups are basically limiting access to certain resources such as CPU, network I/O, memory, the processes that it can see. It's well, the TLDR is basically, it prevents resource hogging, but it's a bit more than that. It separates out these resources and then provides the necessary resource for each. With the C group, you can actually prevent a single container to hog all of those resources, and then basically doing a denial of service with that. C groups, just like many other things in Linux, is inherited by child processes. So if you ever worked with Linux, you know that event processes are in a tree structure. So basically, there is an init process which we usually reference by. Oh, sorry, I put this into full screen. I think I need to share my other screen. Just a sec. Can you see it now? Oh, sorry, I was just informed it wasn't in full screen. Sorry about that. PowerShell, not PowerShell. PowerPoint behaves a bit weird with Zoom. So so basically, the process with PID 1 is basically the init process, and all of the processes in the Linux environment is basically a child process of that. Child processes are inheriting certain attributes from their parents, and the C group is one of those attributes, right? So if you basically, like very simplistically, when a new container is spun up, it's going to create a Docker init process, which is going to get a new, it's going to get new C groups, and then all of the child processes inside the container is going to be forked from that process, which, so because of that, it's all of them are going to inherit the same group. So if you do a penetration test, you get code execution in an environment. The very first thing that you should do, in my opinion, lately, is just to check if you are running on a host or if you're running inside a container. It can give you a good idea of where you are. As you can see, the picture on the left, that's on the host. As you can see, all of the C groups are basically the root C group. And if you check the one on the right, that's actually in a Docker container, which is really easy to tell, right? This is the container ID, and then it says it's Docker. So basically, you know what kind of environment you're running in. So the other technology that is used to separate processes is namespaces. So namespaces limit visibility to resources. Unix time sharing, basically this is used to separate out domain names pretty much. So you can have different host domains to different containers. Process IDs, this is why they don't see each other's processes. Well, partially. The other piece is going to be chroot. I'm going to get back to that. You can also separate mount points, networks. This is why different Docker containers running on the same host can have the same port listening. So it also separates out users and groups, IPC, and even control groups. Namespaces are also inherited the same way that control groups. You can list them out for a given process with LSNS. You need to be root to do that. It basically, the benefit is that they're not going to interfere with each other, right? So if you want to do, mostly if you want to do something with networking, you can do that separately from the rest of them, which is quite great. And the last one is chroot. I think this is the most well-known, probably. Chroot is often called jail, or it was called jail quite often, which I think is a really bad name for it, as it implies that it's actually logged in. If you just use chroot to put me in a different folder, I can get out in 4 lines of C code. So the idea of chroot is that you change, as you know, in Linux, the root folder is basically the very beginning of anything. So everything is stored under the root. And with chroot, you can change that for a process. So if you chroot a process to the /home/me/test, then that's the only folder that it should be able to see, the /test, and everything under it, right? This is to avoid processes getting access to each other's files, and it's also a way to prevent some cross visibility. So I mentioned that process IDs are separated with namespaces. That on its own wouldn't be enough. So if you ever worked with Linux, you know that in the /prots folder all of the processes and all of the relevant information, such as names, such as their namespaces, such as their C groups, or for example, environmental variables set for certain processes are listed there. So unless you actually change the root folder, they still can interfere with each other, and get information of each other. So that's why chroot is used. But as I said, chroot on its own is not enough. The three controls altogether, so control groups, namespaces, and chroot, gives you a sufficient enough separation, reasonable enough separation, so you can work with it. So these are basically the three technologies that underpin the whole container ecosystem, I'd say. There's probably others. As I said, we are limited by time, so we're going to skip some of the details. So with that said, we're going to cover Docker very, very shortly, just the basics. Some of you might know most of the things I'm going to say, but I'm going to cover it for the sake, so that everyone is up to speed. So how Docker works. So Docker is basically, well, originally it was a runtime environment, which is no longer the case. So if you follow this was a big scare for many people when Kubernetes announced that they're going to drop Docker support. The only thing that happened is that the runtime environment of Docker was basically separated from the rest of the company, and now it's called Containerd. Docker is the whole infrastructure around it. They help you manage images and then spin up containers and all of that jazz. The way this works on your normal computer, on a normal host, is that there's a Docker daemon running. This is a persistent process that runs as root, and it's accessible through a socket usually. This is usually a Unix socket, which most commonly stored in the /war/run/docker.sock. It can be switched to TCP, but one thing to note is that underneath all of this, you actually just issuing HTTP requests to the Docker socket. So when you use the Docker command to do whatever, that's just basically a HTTP request, right? So the Docker command is nothing more than a fancy curl package. And one other thing to note is that the Docker socket on its own does not implement any access control whatsoever, right? It relies on the system access control. So basically the access control on the socket itself. If someone has access to the Docker socket, it can issue any command to it whatsoever. And as I said, the Docker daemon is running as root. So if you have access to the Docker socket, you basically own the machine, right? So two things to note. What's the difference between images and containers? Images are somewhat similar to VM snapshot. It's basically all of the files that are going to be used by a Docker container in later on, right? So it's basically just the scaffold that's going to be used, and the container itself is just a running group of processes, as we said before, which is usually based on an image, right? So it's using an image to spin up a container. So that's basically it. I don't know if there's any questions so far. If not, then I'm going to switch over to our environment and then show it. Since no one wrote, I'm going to assume everyone has access to everything. So I'm going to share with you a few links quickly. So we have the following links. One is play.sockshopshock.com. You should be able to log in with the credentials you got. This is where we're going to have our challenges that you can submit answers to. We also have two links. One is victim.sockshopshock.com. It's an HTTP, not an HTTPS. And the same with port 8000. We're going to cover that quickly. Let me share my screen again. Okay. Can you see my screen again? Sorry, I'm just always uncertain.
Yes, we can.
Okay. So this is the play.sockshopshock.com. You should be able to log in. We have some links here as well. Like you can use. Don't worry about the cheat sheet. That's not going to be needed today. And then you also have access to this site. I'm going to give you the credential later on that you can log in. And then this is our web shop, which is going to be our victim today, basically, as you can tell from the domain. I'm going to wait a little bit. If someone is struggling with logging in, please let me know so I can help fix it. Just to give you an idea of what we're going to do, I'm going to show you the application and then show you what exactly is the vulnerability in there. But this is just a web application vulnerability. So on its own, it's not major. As we're going to quickly tell, the web application is actually running in a container. So our job is going to be to get out and then see what else we can access in that environment because of a misconfiguration. And then we're quickly going to cover what preventative measures should have been there and what detection should have been in place to actually detect this issue in progress. All right. I'm going to assume that everyone is in. So let's quickly cover everything. Okay, so if you land on if you get into play.subscuto.com, on the landing page, you're going to find the following little URL. So this is basically how the whole setup is starting. So as you probably heard, if you follow security, IT security related news, there has been a lot of issues that started out with a badly configured S3 bucket in AWS. This is not different from it. So this is just an S3 bucket where someone basically leaked secrets, right? So if you check this, this is basically an SSH log file where you can see multiple failed login attempts for a user called DevOps. And then you can also see login attempts for a really long string that doesn't seem to be a username. It seems to be a password. So if you check the challenges now, the very first question is going to be, I only numbered the first two because the rest of them are not ordered in any way or form. What password was leaked in the S3 bucket? You can just submit this one and that's going to be your first 100 points. I don't know how hard that was to follow. So again, if you go to the landing page on the play.subscuto.com, there's going to be a link to the authentication log there. And then just copy this. I think it's the third line that you see there. It's going to contain that password. And then you can use the same password to actually get in here. So please try that. I'm going to wait a little bit until everyone manages to get in. All right, we have a few first submissions. Did everyone manage to get in? I only see a few submissions yet, so I'm not sure if I should wait or if anyone has any issues getting in. Please just, if so, just please ask it in the Q&A or just chat to me directly so I can help to get in. All right. Okay, so let's continue then. So with the same credentials, you can actually log in to on port 8000 on the victim. This is basically a really simplistic web application that can be used to monitor a Docker host, basically. You can list out containers, images. As you can tell, I'm not really good with front-end development. You have basic networking tools like ipconfig and then list out the root. And then you also have ping, where you can actually submit an IP and then just ping it, right? It's going to return you the result of that. And this is where we get in. It's as I said, it's a really simple web application issue because this wasn't the focus of it. So if you submit an IP and then concatenate that with a semicolon, and then add any Linux command, it's going to run it for you, right? As you can see. So we can actually simplify it as well. Just skip the IP altogether, so we don't see the ping. It's not needed for us. So what can we do exactly, right? So as I said, once you get in, the first thing to check is if we are running in a container or not. So a really easy way to do that is I'm just going to cat out the C group of the PID1 process, right? As I said, if this one is not just root, that means I am running inside a container, right? And that's our second question, basically. What is the name of the process with PID1, right? What is, oh, I'm sorry. What is the C name, not the name, sorry. And that's the C name of it, right? This beautiful little string. All right. So, okay, we know that we are running inside a container, but we also know that we have access to running containers and images. So that must mean that we have access to the Docker socket, right? Otherwise, I wouldn't be able to actually list those out. So that means I can actually do something. Okay, I'm going to bring in Visual Studio Code. And then let's see what we're going to submit, right? So that should mean I should be able to run simple commands. I don't know, can you see this, or should I increase the size of the text? So basically what I do here is I'm going to run an Alpine Linux and then just echo out tests just to see, just to confirm that I can actually run Docker commands, right? And as you can see, it actually works. Okay, so given the fact that we have access to the Docker socket, what else we can do? So let's see if we can get access to the actual host file system, right? Because that's our holy grail, right? If you can get access to it, that could be great. So this is what we do. So again, I'm going to run a Docker container. Again, it's an Alpine Linux. And I'm going to use the -v, which is used to mount up stuff, right? So I'm going to use that to actually mount up the root file system of the host under pound, and then just cat out the /pan/etc/shadow, right? So on a normal environment, the etc shadow file should contain all of the password hashes. So it's a common favorite proof of concept code just to see if we have access to everything. Because if I have access to this, I probably have access to everything on that host. So let's see what happens with that. All right, we have access to the shadow file. And it's not that hard. We just mount up the folder. So since we have access to the Docker socket, which I know it sounds like a stupid vulnerability, but if you go up to Docker Hub and check some of the application, it's often recommended to expose the Docker socket to the container because it's something similar, something to help you monitor your environment. And I also see in a case, this was a really well publicized breach about 9 months ago, I want to say, where developer wanted to work from home. So he basically exposed the Docker socket over TCP on a public port. In about 5 minutes, automated bots were running cryptocurrency miners, basically. So it's relatively, it's a straightforward bad idea to do this, and it's still happening quite often. So, okay, we know that we have access to the host file system, right? So from there on, we can actually edit any file we want, including authorized keys, so we can get in. But there's also another interesting vector. So if you check again the containers running, there's a few that sounds quite interesting. So let's see. We should have yeah, there you go. There's one called the user database, which is always nice, and then there is one called the catalog database. All of them sounds really, really interesting. So let's see what we can get out of those, right? Because obviously we can run Docker commands. So, okay, let's see this one. So we know that the catalog file, the catalog database is called TMP catalog DB1. We know it's a MySQL server. You can see that if you list out the containers. So we're basically going to use a MySQL command in it and just see what kind of databases are we dealing with. So you can see that we have information schema, MySQL, performance, and SocksDB, right? So it's relatively simple to move on from there. So the only thing that sounds interesting to us is the actual SocksDB. That's probably going to contain everything relevant to the SOC shop that we can see here. So let's see what happens there if you submit that one. Okay, something is off. What did I do wrong? Oh yeah, there's a missing quotation mark. Sorry about that. There you go. So we have the following table: SOX tag, and tag, right? Okay, so let's get the actual data out of it, because why not? Again, I think I'm missing a quotation mark, but let's see. So again, we're running in the same container. Again, we're running MySQL in there. But this time I'm actually going to pull everything from the socksdb.sox. There should be a dot there. That's the problem. There you go. So this one is messy, but if you check it, the first line is basically the columns in this table. So we have SOC ID, the name, the description, the price, the count, so how many SOCs they do have, and then 2 URLs to images, basically. And you can see that the prices are still like somewhat what you would expect. So if you check the actual SOC, like those are the prices in there, right? So we can actually go one step further, and since we have MySQL root access, we can actually do something like this. Basically update the prices, right? Again, since we have access to the socket, we do have access to all of the containers, and we can, even if you running the container as a non-root user, since I access the Docker socket, I can run it as root even if you want to prevent that. So let's go with that. Okay, it shouldn't return anything, but if everything goes as planned, there you go. It's the best sales ever. So basically, we managed to reduce the prices relatively quickly. And the interesting thing with the container, the whole container setup, is I didn't actually compromise the web shop itself, there was another application running on the same host. This is especially interesting, or could be really interesting, if you use a shared hosting provider where the separation is not as good as they claim to be, because then someone could deploy a simple WordPress application that is not protected properly, and then they get owned, and because of that, you get owned, right? So there was another database, if you remember, the user database, which also sounds like an interesting target to me. So the user database is actually a Mongo DB. So we're going to go and see what kind of databases we can see there. Okay, so we have admin, local, and users. So if you haven't worked with Mongo, admin and local is almost always there, so it shouldn't be that relevant. But yeah, users sounds like something we should get in. So we're going to dump the collections in it. The collections are basically this was somewhat similar to the collections, the tables in MySQL. So it's basically like a group of things. Like inside users, as you will see, we're going to have addresses, cards, and customers. All of them sounds like a really interesting targets in my opinion. So let's start out with dumping out the cards table, right? That's always a fun one. Okay, so we have long numbers, expiration dates, and CCV. I wouldn't recommend screenshotting this. None of them actually work. So this is fake data, but the interesting thing is that the sock shop setup wasn't built by me or by us. It is something actually available online, and they choose to go ahead and not encrypt this data, which is an interesting choice in my opinion. So we also, okay, we had users. No, maybe user. Okay. I need to see again the collections. Oh, sorry, customers. All right. So let's see customers, and then there's going to be addresses as well. Just dumping all of the database out, and then see what we have. So this is the user database. So we have username, we have first name, last name, and then password hashes. So I don't know if everyone knows what a hash is. So a hash is basically so when they store a password, they're obviously not going to store your actual password. So let's say your password is password 1, which it shouldn't be. They hash that down, and then they store the hash. If you provide the same password, the hashes are going to match when they check it, so they know it's actually your password. But they cannot actually restore your password from the hash. So a common way attackers are actually trying to bypass this. They actually built really large dictionaries with hashes and then corresponding passwords, right? And then instead of actually trying to brute force your password one at a time, sorry, they're actually they're just going to look it up in that dictionary, right? And then obviously, because those became so prevalent, there was a quick response from a defensive side. They started to add salts to it. So the interesting thing here that we cannot see because the formatting is off, but let me show you. We have to copy this out just to make it a bit easier to read. So sorry about that. Okay, so we actually have the salt as well. So the way they use salt, they generate something random, add it to your password, and then hash it together. The reason this is useful is because they cannot pre-build dictionaries. They actually have to do a new dictionary just for you. So it's a really clever way to avoid this kind of attacks. But in this case, it's actually stored at the same place, which means we have access to both. Obviously, it's still going to be a slow process to actually hack it, but we have a better possibility now because that was available to us. All right, and then let's go to the last one, addresses. So we have addresses to all of the corresponding users, right? If you are responsible for the security of a company, this is where you're going to start to scream again. I mean, if this gets out, it's a really bad thing to have, right? All right, so we basically managed to get out of our container, basically get access to the host read files and even write files, and then we managed to get all of the databases as well. So once we have this, there are multiple ways to escalate your access. Does anybody have an idea on how to get from this to actually having access to the hosts, like having full shell access to the host? How would you go about it? Is there any answer to that or any ideas? Okay, so if not, then okay, there are multiple ways to go about this, right? One of the easiest that could come up is just editing the authorized keys on the host. So basically, I'm generating a new SSH key, adding it to the host, and then SSHing in simply. The problem with this one is that most of the servers you're going to face is going to be behind the DMZ, right? Which means you won't have direct access to that host normally. I've seen exceptions, but it's getting rarer and rarer to have that. So you need to find another way. So the easiest way to do that is actually get something called a reverse shell. So the way reverse shell works is when I have code execution on the victim, instead of me connecting to the victim, I ask the victim to connect to me, right? Because the victim actually can reach out to the internet. I cannot reach the victim. So basically that's the idea. So that's what we're going to see. This can be a bit too much at first, but bear with me. It's quite simple. So on the right, what you see is Metasploit listening for incoming reverse shells, basically. So this is just Metasploit waiting for a connection from a remote host on port 444. And then as soon as that happens, it's going to pop us a shell, basically. On the bottom, we have a really simple HTTP server. The only thing it's doing is basically serving the payload that we are feeding the victim, right? And at the top, we have a Python script, which is going to inject commands into the same field that I was doing before, right? Just injecting a code here. That's about it. So it's basically doing the same thing that we discussed before with checking the C group, and then it's checking containers, and then checking images. And then it's doing the same proof of concept that I showed you before. It's basically getting access to the host file system, right, with the -v, and then just getting out the shadow file just to prove that it can do that. There you go. And then just going through the same database things that we did. Just checking the MySQL database. I'm not going to bore you with that. And then the MongoDB, the same thing that we did before. Okay, that's it. And this is where it gets a bit more exciting, right? So what we're going to do here is going to run a container which has access to the whole file system. And then it's going to reach out to basically our attacker machine with a simple vget. So it's just going to download a file called cron.sh, and then it's going to run it, right? So let's see what that file is actually doing. Okay, payloads cron.sh. Okay, so I don't know if anyone worked with cron. So the idea of cron on a Linux machine is if you have tasks that you need to run on a schedule, then cron is going to do that for you. You can define how often, and it's going to run the code for you. So what this command is doing, these two commands basically, is just going to add these two lines, so the lines between the quotation marks, to the cron tab on the host, right? Both of the line says it's going to run every minute, it's going to run as root. The first one is just going to get an ELF binary, which is our reverse shell payload, basically, save it to this file, and then add executable rights on it, and then just execute it. So this is basically just going to make that reverse call that I told you. It's just going to reach out to the attacker and then say that, here I am, please take control. And then the second line is going to remove all lines from the cron tab that runs every minute. So basically, this line is going to remove these two lines later on. The reason for that is I don't want to run it really every minute. I only want to run it once, right? And I also don't want to leave any footprints that I was here. So it's just cleaning up. So this is why it's going to run. So be careful. If you see, as soon as I hit enter, it's going to make a GET request here in the bottom. Just watch for it. There you go. It took the cron.sh. And that was 44 seconds. So in about 16 seconds, we should see another GET request. And then we should see your shell pop, basically. There you go. As you can see on the right, we have a session on session 1. And this is basically, so if I get a shell here, I am root on the victim. As you can see. So basically, I own the system. I mean, I can throw out people if I want to. I can revoke all of the SSH access that they have at the moment, and basically own the whole computer. I don't know if there's any question so far. How, why, and what happened exactly? Okay, if not, I'm going to go into a platform called Prisma from Palo Alto that was actually running on the background, just to see what was actually visible while we were doing this. So the way, okay, I'm going to get rid of this. So the way this tool works, as we said before, containers are nothing more than just a group of processes on a host, right? So what Prisma is doing is actually deploys an agent on that host, and then it's going to monitor everything that these containers do. It's going to map it out, right? So this is our current setup. You might recognize a few things that we run into before. So there's the catalog database, that's the user database, and then this is the web application we actually attacked. You can see how they are connected, right? So the normal problem is when you go into an incident response on a Linux machine, unless you have some source of forensic information, it's not that easy to actually figure out what happened on that host, right? And this is where this whole setup comes into play. So if you go into events, you can actually see all of the alerts that was raised by the application that we attacked, right? Unexpected processes popping up. So if you have basically the whole timeline of our attack going through. So this is where I started to inject. If you remember, this is the first who am I command that I did, just to prove that we have that. And then we go into checking the C group of the PID1 process, and then going to everything else. Where is it? Oh yeah, this is where I do the tests just to see that we can run a container. And then this is where we start to actually get access to the container, the host itself, right? So basically you can follow up the whole sequence of attacks as they happen, right? Which can be a really powerful tool in an incident response. It could also help you with preventing this kind of issues. So as I said before, the Docker socket is just an HTTP listener, basically. So one thing that you can do in Prisma to prevent this kind of attack while still keeping the user usability of the application is just actually use it as a reverse proxy and then filter out unnecessary calls. So you can basically allow everything except, allow only container list and an image list, and it's still going to work as before, but it's not going to allow this kind of attacks. Okay, so that's basically what I have. So that being said, we still have 3 questions. I actually shown how to solve those. So I would encourage everyone to go through those and see if you can actually reproduce it. If not, please ask questions. I can give you a few of the POCs, so you only need to fix it up a little bit. But it's learned by doing, I guess. So let's see. I give everyone about 20 minutes to explore. If there's any questions in the meantime, please let me know. Right, we have 2 submissions, so two helps to go ahead on the big question: how would you change the prices? I've seen a lot of good submissions. There was some issues with spaces there. Just write the command, should be fine. And on the credit card numbers, if you remember, I actually dumped the credit card numbers, so you need the the usual 16-digit credit card numbers, and that should work. Right, we had quite a lot of good submissions. The only thing that haven't full yet is the how to get access to the credit card data. So I'm going to show you quickly again how it was done, just to give you an idea of where to move. Let me share the screen again. Okay, so obviously, if you remember, it was the TMP user database one. So you can actually check out the collections with this command. So I'm going to post this pre-scene, sorry, you can use the Mongo export to actually go ahead. So if you remember, there was cards, addresses, and then customers. And this is a really simple way to actually work with it. I'm not going to dump the same, but instead of the ID, it needs to be the card number, which is, you know, the usual 16-digit one. And submission seems to be going down. There's a few completionists. So congrats. This is not an easy. So if you haven't done pen testing much, this is not necessarily as easy thing to do. I know, but it just gives you a feel on what's possible, how it's usually done, and just an idea. It's just give you an idea that just because you're in a container, it's not exactly secure. I think that was a common mistake. It was the same issue in cloud. Everyone assumed as soon as you move to cloud, it's going to be secure, which is not the case. You just have different vulnerabilities, right? So I quickly want to touch on what else should have been done to prevent this. But I'm going to give you 2 more minutes just so everyone can finish, because it seems there's a few tries still. All right, we have a few more completionists. Nice, congrats. All right, so okay, let me share the screen. Can you? Sorry, wrong screen. I hope everyone can see the screen. Okay, let's get to the end. So what else could have been done? So in our opinion, the whole DevOps environment needs to rethink security in a lot of way. If you check on like an average agile company, you're going to see an insane amount of releases day to day, which means the old school approach of being a gatekeeper and then just trying to see everything before it gets released is no longer workable, right? So our approach is to basically inject security into the pipeline at every possible way where we can and automate it as much as possible. It shouldn't be done by hand. It shouldn't be hard to do by developers. And it's definitely should be continuous instead of like reoccurring as old school. I'm not arguing against doing penetration tests. Those are still important, but some parts should be fixed when during the development instead of after release, right? So basically, our idea is to define all of the requirements that you have, all of the standards, all of the frameworks for risk assessment. You need to be able to prioritize later on, have a common language for bug classification, so everyone understands what to do with that certain bug, how quickly do you need to react to that, And then you need to have your exception flows, because every rule that you're going to set up in your environment is going to have 55 exceptions for it. There's always, in the end, the whole environment is about releasing new things and being functional. You cannot stay in the way of that, which means you have to have really, really good exception flows. And I don't just mean to quickly enable exceptions for developers. I also mean to have a framework where revisiting exceptions that you raise temporarily should be checked regularly. So let me give you an example. If you are in an environment where you control to what IP addresses they can open up certain SSH ports, for example, right? Which you should do if you don't do it at the moment. Obviously, going to be exception to it. Sometimes developers need to work with external people, which means they need to open up the port to that external Office IP. So you need to be able to handle that. The problem I often see is that they have a proper process to actually enable that, but then no one ever is going to revisit that IP address and see if that's still relevant. You might no longer have that connection with that company. You might not even, they might not even have that IP. So it's just generally a good idea to regularly check, and this should be automated. If it's going to be done by hand, it's going to have issues. And then we also recommend defining some baseline for design, doing proper reviews, doing the threat modeling. If you give the right tools to the right people, they're going to be amazing at spotting security issues. Developers are really good at this. They're going to be, I argue, they're going to be better than security professionals because they know their code better. If you give them the right mindset, you give them the right tools to do it, they're going to be really good at this. Data classification is another one. Obviously, depending on what kind of data you're going to handle, it's going to require different baselines. So, for example, when we've seen that database that had user data and then credit card data, that's going to be handled differently than the catalog database, right? And then during the implementation phase, I highly recommend automating some of the requirements. That means that some of the things that you're going to require from them, like defining context in repositories, should be code lifted automatically. So instead of requiring the users to do that by hand, you should be able to push that out to all of the code bases if you need to. And then doing static code analysis, and then just to confirm that there's nothing in there. So if you take a look at our example today, that code injection bug, that would have been coded by any static code analyzer because it's such a simple code. Yet it occurs really often. So a simple static code analyzer, which can be open source and free, as long as you know how to configure it, could have prevented this kind of issue. Then having vulnerability scanning as well in place. So the reason I separate that, I'm talking about third-party libraries. So most of us are going to rely on a lot of things, JavaScript libraries, Python libraries, all of that, just depending on what your stack is. And for some reason, we ignored this for a long time, which I don't think is an option anymore. There's a lot of really good tools that helps you not, it's basically helping you by notifying you that there is something vulnerable in your stack, right? They can even do automatic code lifts, so you can actually merge like 15 minutes after vulnerability is released, which is just amazing. Then there's a verification phase. I would say this is the least important part in this. So this is dynamic scanning and fuzzing. This is basically the phase where you spin up a test environment and then just scan it actively, and then do just some basic fuzzing to try to provoke some unexpected behavior. I'm not saying it's not valuable. I think it's highly valuable, but until you fix the rest of the things, it's going to be really, really noisy. And then I also recommend checking what's going to get release time or runtime during runtime. So have a finer security review if it's a really major release, or if it's a new first release for a code base. Store that all of the incident response plans. So if you have an application hacking like what we've seen today, and then the whole issue comes up, so you realize that you have been breached, how do you go about fixing it? It's not trivial. you need to know about it, and then the application development team or the application, the team responsible for the application needs to know it as well. The problem is you might have multiple application or hundreds of application in your environment. You might not know all of them. Like simple questions: what can I shut down? What can't I shut down? Because even if we are breached, it's still important to provide service to the users. You have to have these questions really quickly. So having an application-specific incident response plan, I think, is key. And then having monitoring and alerting in place with runtime monitoring. So what we've seen in Prisma, if you don't know what's going on, you're not going to know about breaches. Check some of the literature out there about how long it takes usually to companies to discover breaches, and it measured in months and years, not even in weeks, which is just appalling. If you have the proper monitoring in place and then set up the necessary alerts, you're going to be notified about this kind of thing really quickly, and then you can fix it before it spreads, right? If you have a single application that was, like in our case, the first time there was an unexpected process, that would have been an alert and someone would have been already on it before I actually get to the card data. You might not have that quick of a response, but again, at least you can fix it relatively quickly, as opposed to realizing only when they're starting to ransom you. The same goes for runtime monitoring. I don't think you're going to get everything from application logs. In fact, I would highly encourage you not to rely solely on applications log. The point of application logs is to know if anything goes wrong from a functional point of view, which might be useful, but might not be. I think it's just a good idea to have that in place. And then secret management is another great one. I way too often I see that people either hard code secrets in code, which is just a big no-no, or they actually used environmental variables, which is well, it's not a big no-no, but it's a no for sure. Having a proper secret management in place helps you with a lot of things, including the proper protection of it, key rotation automatically if you need to, and then just having visibility of what is used and when. There's a lot of open source tools to do that. And then there's a few supporting projects I highly recommend. Building a service catalog is one of them. If you have an issue, you need to know who's responsible for who, what is touching what is the data classification of that service, and so on and so forth. And then having a general data dashboard, a security data dashboard, just to give you an idea on components, the issues that you have in each components, and then not just about components, but about teams as well, right? If you start to experiment with working with different teams, teaching them, providing training, or just having discussion with them, you want to see if there's actually any effect of it, right? You just don't just throw stuff into the wind and then hope for the best. You actually want to see what's going on. And the security dashboards, if built properly and you have the proper data, it's going to be amazing. Not least because in the end, all of us are going to report to management or to board, and showing the fact that the number of vulnerabilities introduced to the production environment is declined to 10% of what we had last year is going to ensure that you have the proper budget next year, which is, I think, everyone's best dream. And then the last one, which I cannot emphasize enough, is an automation platform. I don't promote any specific tool here. There are open source options, which requires more work, and there are paid platforms that are going to cost you money. Quite a lot usually, but having automation is I think is important for multiple reasons. One, I'm a really lazy person. I'm willing to work really, really hard to avoid working. Automation is the way to do that. It's just going to be easier to do this boring stuff, and that's the other part. If it's something repetitive and not really engaging, people are going to make mistakes in it, right? If you ever try to do the same things for 8 hours, you know you're going to make mistakes. Automation platform doesn't do that. It's going to be consistent. If you do a hiccup in the automation, that's going to make mistakes, but you can correct them. And once you fix them, they're going to be flawless, right? The other piece is your mean time to response is going to decrease significantly, right? If an alert comes in, and let's say best case scenario, everyone is in the office, they get the alert, they're not on coffee break, so they get it. Maybe it's going to be 15 minutes. With automation, it's going to be within a few seconds. And then I haven't even talked about the worst case scenario. Let's say you don't have out of hours coverage. the issue hits at, I don't know, 10 p.m. and then it takes a further, at least 10 hours before anyone is in the office and actually fixes it, right? Automation is going to do the first steps. It's not going to fix everything at first, at least, but it's going to do all of the first steps, maybe even doing an isolation if it's authorized to do that. So you can come in later on and actually, wrap up the incident response. So yeah, I think automation is going to tie all of this together. I'm a big advocate of it, and highly recommend getting into that field. I think it's going to go really big in the coming years to come. So that's our idea of supporting security in an agile or in a DevOps environment, whichever buzzword you like. Yeah, that's our answer to the challenge, basically. I don't know if there's any questions regarding that, or is there any note or anything I missed, haven't explained properly? If not, then thanks so much for bearing with me for so long. I know I can be rambling quite a long time on this kind of topic, so I really appreciate staying with us, and hope everyone learned something and had some fun in the meantime.
Absolutely. Thank you for